Assalamu alaikum everyone. All praise is due to Allah for the effective completion of this project. Myself MD Rakib Hossain and my project partner is Jasim uddin. Alhamdulillah, today's presentation will be the finale for a year-long journey. Here I am going to discuss about design and implementation of an aerator pumping system for biofloc fish farming using 12-volt battery with a controller. Before we start, I want to thanks to my supervisor, Professor Dr. Khosram Selim sir, for his support and he gave us enough time in laboratory at IUV at this pandemic situation. Firstly, this is our outline. Here we actually discuss about background motivation and objective, existing system, literature, review, problem and challenges, possible solution, problem statement, proposed system, theory, simulation, hardware prototype, result, analysis, addressing engineering activities, also conclusion and future work. Now, this is the background and motivation. In our research is about actually design and implementation of an aerator pumping system for biofloc fish farming. For this, first we should know about biofloc technology. Biofloc technologies depend on elevated power input in order to aerate culture system water. Biofloc innovation is a procedure of upgrading water quality through the expansion of additional carbon to the aquaculture system. Through an outer carbon source or elevated carbon content of the feed, the natural agreeable hydroponic system called biofloc innovation, simply BFT, is actually considered as a protein pro-efficient elective system since nutrient could be continuously recycled and reused. This system actually changed the toxic material like ammonia, nitrate, and nitrate into a beneficial product called proteinous feed. Now, that is the another background part where we actually discuss about aeration system. After knowing the biofloc system, we need to know aeration system because our project mainly based on this topic. The need for aeration in biofloc technology is well documented. Not only is dissolved oxygen required for breath by the organic creature in generation, but it is additionally required for aerobic background or organic within the water column. Transformation of ammonia or to nitrate and water, after that to nitrate by the biofloc. Aerator actually distribute the oxygen into the cultural tanks, and extra advantage of air circulation is the explosion of gases from the water segment, which can greatly affect generally water quality. It maintains high stocking density and productivity also. There are lots of aeration system available. Some of like a diffused air system, surface aeration, vertical pump aerator system, propeller aspirator pump aerator are actually a common types of aerator in here. This is another background and motivation continue. There are many problems and challenges in the existing system which we actually include here. Some of the main problem are actually the existing system consume high power. These system are very complex in design, so the price of this are very high. Existing aerator actually making much noise also. This is here we actually showing three most common research paper which is actually the related to our topic, and we go through this research paper. First one is actually a ponderator which is made by a person named Shuhel who is from Gazipur. Another second one is actually another Bangladeshi biofloc aerators research paper. Third one is from another one who is in Kolkata. This three reference paper journal conference paper. The outcome of first one is SER pump which using generator for backup power. Second one is a big aeration system which consists lots of pump. They also use generator in their system. In third one, their system consume low power but very expensive because they use high product in system. The limitation of this problem and challenges actually is complex in design, also high cost system, high power consumption, very expensive. So our possible solution is actually want to make an easy system using simple material, make a system with low power consumption with BFT controller, develop an efficient aerator pumping system by using 12-volt battery. This is the problem and objective. After literature review, the following major problems are discovered. We use existing air pump and modify it for 12-volt battery in this project. We introduce BFG technology in biofloc aerator. The objective of our proposed system actually is design and developed of an air pump by using 12-volt battery. Also control this pump with BFD. Develop BFD for the controlling air pump to compare the aerator pump with the existing system. We want to introduce a low power consumption system. Our system, we actually create a portable system, where since we are not actually create any portable box or something. So this is our proposed system. Here we actually talk about methodology of aerator pumping system for bifloc fish farming. The system configuration actually, we need a 12-volt battery, a BFD controller, single phase low voltage motor, ER tube, ER stone. Here the main part actually addressing complex engineering problem. Here in complex engineering problem WP1, depth of knowledge required. In our project that requires knowledge of motor, air pump, bifloc aerator, bifloc system, inverter system, PCM simulation. For hardware implementation, we need to know motor winding, coil removal, BFD controller are also used in this project. Range of conflicting requirement, no conflicting requirement actually on any issue. Depth of analysis required, WP3. People used a CR pump for this. The need generator for load shedding time or the backup time. DC pump are rare and complex in design, so we just modify an existing system which people already used in SC. So we want to modify it by DC using 12-volt battery, and also we use a controller to control this air pump. Familiarity of issues, we need to familiar with BFD, motor winding system, coil removal, extent of application codes. No need to learn any applicable codes. Extent of stakeholder involvement. People of aquaculture and biofloc related fish farmer are the consumer of our project. Interdependence. This project involves a number of interdependent components. Without motor and the controller, all the components are actually interdependence. Addressing complex engineering, another part was EA1, ranging of resources. The necessary equipment are inverter, battery, air pump, pipe, wire, and copper. Overall, we spent this project actually 5,000 taka for buying this component. Level of interaction, nothing here. Innovation, actually design and implementation of aerator pump by using battery and also control it. This is our innovation. Consequences to society or environment. Our project can be used in biofloc systems. Small aquaculture fish farmer also get benefit from it. Familiarity, we need to familiar with biofloc system, aerator, pond aeration system, aquaculture system, battery based motor, inverter, etc. This is the theory part. Here we actually discuss about the proposed method design. We design our proposed system of bifloc aerator pumping system in practically. This is a simple design which actually consists of an air pump, 12-volt battery, PFD, air tube, air stone, lots of things are in common. We modify an existing air pump. Firstly, it will throw the air into the pipe. From this pipe, we will connect some air tube with air stone, which will actually pass the air to our tank. That's all. Now I want to invite my fellow partner Jasim to discuss the rest of the topic. Thank you.
Hello everyone, Assalamu alaikum. Thank you, Rakib. Next. Now I want to talk about the BFG technology. Here is a simple single phase variable frequency drive block diagram. A variable single frequency drive BFD might be such an engine regulator that drives an electrical engine by shifting the frequency and voltage provided to the electrical engine. Here in this project, it works to control the power. By this, we may increase the flow rate at low voltage. It also reduces the energy consumption and energy cost. It also works to extend equipment life and reduce maintenance. Next slide. Here is our hardware prototype. In figure 1, this is our project prototype. We make it in our GRC lab. We also test it several times in lab and check the data. Figure 2 shows the working time at IIB when we test our project. Next slide. Here is the video of our project. We shoot a video in our working time. Here is the PCM simulation of single-phase variable frequency drive, which is based on 4 MOSFET. This 4 MOSFET has 55 ampere current. These are high current MOSFET. Here is the value of this simulation. Next slide, please. Result analysis. This is the result analysis of this simulation. In figure 1 we are showing three reference voltages, BR1 and BR2, showing the sine wave where both has 50 Hz frequency, and BR1 has 0 degree and BR2 has 180-degree phase angle, where BR3 is showing triangular wave with frequency of 20,000 Hz and phase delay 180-degree. Figure 2 shows the output signal of this simulation. Here this is showing a periodic duty cycle where we got the positive half cycle. Before modify our pump we can't control the motor. This time we can control it. We change it frequency 40 to 50 hertz. That means control the frequency. This is actually the output of our simulation. This is the switching signal from the control. We use the 4 MOSFET here. This is showing the signal of this four showing different signal. Next slide. Here is the main data which we measure in our IB lab. At different current, we measure the flow rate of this air pump. To measure this flow rate, we had no device which is directly measured the flow rate. So we take an alternative way. We took a 30-liter bucket and 5-liter water bottle. After that, we measure the time and calculate the flow rate. Here you can see when we increase the current, the power increasing and the also flow rate increased. The maximum power we found was almost 80 liter. Also maximum flow rate was 37.5 liter. At this time our flow rate was not very high, but in future we will work to increase the flow rate. Next slide please. The environmental friendly aquaculture system called BFG Technology is considered as an efficient alternative system since nutrients could be continuously recycled and reused. Environmental friendly model as there are no harmful emission occurs during the process. It also cost effective, reduce power consumption, so it will be sustainable. Next slide please. Conclusion. This aerator has been designed, developed and tested for fish farming. The performance have been evaluated and validated with actual data from the testing. We designed the BFG controller at our lab. At the moment, the initial developing cost of the system is quite high, but when we go in commercial production, the cost will reduce gradually. Next slide, please. Future scope. In future we want to make this at commercial scale in big size. We also develop good and attractive mechanical structure. We will try to increase the flow rate, and we also try to reduce the noise. Already we make this system less noisy. We use solar panel in future. These are our selected references. Thank you.
Okay, thank you.